Hello everyone. Welcome to the day 8 of Python series. In today's session, we'll be learning about exception handling in Python. So let's see the agenda for the session. First, we'll be talking about how to handle exceptions in Python, and then we'll be also performing a hands-on on different types of exception handling. So that's all with the agenda. Let's start with the session. But before we begin the session, make sure to subscribe to our channel and press the bell icon so that you'll never miss any update from us.
What are exceptions? So let us understand that. Firstly, let us look at the definition of exceptions with regards to programming. Programming, an exception is defined as an event which stops or interrupts the intended flow of a program's execution. So, as a programmer, when you write code, you have an intended flow of how your code blocks will execute, in what particular order, and what exactly you need to execute. So, anything that comes in between, anything that occurs out of the blue, any exception, so to speak, any error that happens that is unaccounted for will totally interrupt your flow, and that is called an exception. And we need to deal with that in programming sense because otherwise we can break our applications. Right. So let's look at this from a technical perspective. There are two types of programming languages that exist. So the first is compiler-based languages, and the second is interpreter-based languages, right? So in compiler-based languages, what happens is all of the code is firstly compiled and converted into bytecode so that the machine can execute it all at once. So in this particular case, before the execution of the code is converted into low-level language, right? The entirety of the code. So in this particular case, what will happen is you'll basically have your code structure where the code starts. There will be a code module one, a code block one that will execute, which doesn't have any errors or exceptions. So it will execute successfully. And then if you encounter a code block or a part of the code where there is an exception, a code block, so it will simply throw a compiler error that there is an exception over there or there's a code error over there. Simply go and fix that. But it will not interrupt the code module 3, at least in the compiler sense of way. The module 3 will compile successfully, and you can even run the code and it has a chance of running successfully. So this is called compiler-based languages. These are like, for example, we can take C, C++, Java. These are compiler-based languages. All of the code is first compiled and then it is executed. So on contrary to that, we have interpreter-based languages. Now, in interpreter-based languages, the entirety of the code is not compiled. It is just executed line by line. Right. So Python is one of those languages. Obviously, Python is an interpreter-based language. So the workflow of interpreter-based languages goes something like this. So the code starts line by line, right? The first code module is executed because it does not have any exceptions. It is correct, so it is executed. So the next code module where there is an exception, when that is encountered, right? What that will do in interpreter-based languages is that it will stop the execution altogether. So the next code module will not execute either, right? So what happens essentially in this particular case is that even if the code module 3 does not have any exceptions, it is completely logically correct, right? It will still not execute. So in interpreter-based languages, not handling exceptions could lead to the entire application breaking, right? So we want to execute things that are correct, right? Even if code module 2 is wrong, we want to resolve that particular issue and we want to move on to code module 3. So unless we handle these exceptions, that is not going to be possible, right? So exception handling is meant to deal with exactly this. So let us look at the workflow of this particular case if we handle the exceptions. So how to handle exceptions in interpreter-based languages? It is sort of the same for compiler-based languages as well, except we all know the logic of whether all the code modules will compile or not in compiler-based languages. In interpreter-based languages, we do not need to concern ourselves with that. Uh, what exactly happens over here is that the code module 1 will execute successfully as it should. When the exception is encountered in code module 3, we can see a little bit of change in the flowchart, except for the arrow, instead of the arrow pointing downwards from code module 3, right over here, as we can see, the arrow goes to the right, and it basically goes into the condition which says that if there is an exception, execute this part of the code on the right hand side, and then continue as usual to code module 3. So even if there is an error in code module 2, we have created a fail safe for that essentially in this if exception clause. So whenever there is an error which is encountered, we go to the if exception clause, and then the if exception clause continues on to code module 3, and we are able to execute the entirety of the program as much as possible without actually having to stop the execution at all, right? So this is how exception handling happens in a diagrammatic view. So now that we understand the workflow of exception handling in Python, we can look at some examples of exceptions that can actually occur in Python in day-to-day programming. So we'll look at some simple ones so you understand the concept. The first one we're going to look at is called the zero division error. Now, the error name is pretty straightforward. It happens when you try to divide a value by zero, or you basically try to get the remainder of that particular value by zero. So, the modulo operator or the division operator. So, essentially, if you understand this arithmetically, when you try to actually do this in theory, what happens is you get infinity when you divide a number by zero, right? In computational terms, you cannot actually compute infinity. So to deal with that particular issue, what programming languages do is that they throw an exception when you try to run this particular operation, right? So you can design cases to deal with this particular exception if it happens. Other than that, this is what the error is called. It's called the zero division error. Then we have the name error. Now, in name error, what happens is when there is a variable name that you're using, which has not been defined previously, right? And you're directly using it, it'll throw a name error. For instance, if you try to write a statement which is a equals to b plus 3, and you haven't defined the value of b, right? Then it'll throw a name error because this b variable has not been defined. Then next up you have type error. Now the type error refers to data type mismatch essentially. So what happens in this is when you try to basically perform an operation where there is a data type mismatch. For instance, in this particular example, we can see that a equals to hello, which is a string value, plus 4, which is an integer value. We are trying to add an integer to a string without any implicit or explicit conversion, right? We're not trying to convert this particular integer to a string value and then trying to add it. We're trying to add it as a numeric value itself. Now, in programming logic, that cannot happen. We need to convert this 4 into a string if we want to add it to our hello value, right? So in this particular case, it'll throw a type error because there is a data type mismatch between string and an integer. So, if programming languages have defined a variety of exceptions, there must be a way to deal with these exceptions as well. So, what happens essentially is that every programming language has its own way of dealing with these exceptions, right? In Python, there are ways as well. So, let us understand what is exception handling first. Exception handling theoretically is defined as the process of adding fail-safe measures into the code to keep the program running in case of an exception, right? So it's essentially used from the application point of view to stop the application from breaking when an error is encountered, right? So let us understand the various methodologies that Python implements to deal with these particular exceptions. So firstly, we use the try block, right? So the try clause is used to define the block of code that you intend to successfully execute if no exceptions occur, right? So instead of writing code straightforward, like writing print text without the try block, what you'll do is you'll simply write the try, and then you'll indent a print statement after the try, right? So this print statement is now under the try clause. So if an exception happens, you can now handle this particular exception. Instead of the program simply giving you an error and stopping, you can now find a way to deal with this particular exception. You can try this code. If this does not work out, you can deal with the exception that happened. So next up we have the except block, right? So the except clause is used to define the block of code that you would want to execute if and when an exception is encountered in the try block, right? So say in this particular case, suppose the print statement fails. So when it fails, the control goes to the except block and it will print exception, right? So you can deal with this various ways. You can add various categories of exception in front of the except clause to deal with that particular exception only, which we will see in the example that we are going to execute. But this is how you would deal with a particular exception. When you try a part of code and it does not execute successfully, you can straightforward go to the except block and execute that statement, which is present in the except block. Then you have the else block. Now this is an optional block of code that you can use. It is used to define the block of code that you would want to execute optionally if no errors occur in the try block. So say if the print statement executes successfully, the except statement will obviously not execute because you haven't encountered an exception, but the else statement will execute because the try statement did not have any exceptions essentially. So it will basically print the value of X and then it will print no errors. Then finally, we have the finally block, right? So this particular block of code is also optional in exception handling. You can use this particular block of code when you want to execute a particular set of instructions, regardless of whether an exception is encountered or not. So the finally block of code will execute whether an exception has been found in the try block or whether the try block has successfully executed. It will still execute. So in this particular case, whether the exception prints or the value of X prints, the will always execute will always print. So this is essentially how you handle exceptions in Python. So now that we understand how these four particular clauses work, we can now move on to the demonstration part of this particular tutorial. So let us see how exception handling works in an hands-on experiment.
If you want to make a career in data science, then Intellipaat has IIT Madras Advanced Data Science and AI Certification Program. This course is of very high quality and cost effective as it is taught by IIT professors and industry experts.
So let us now see some of these exceptions in action. So firstly, let us try to execute the name error. So if we try to do this, A equals to B plus 1, right? And we execute that. So it simply gives us a name error, right? So the way we can deal with this is by simply going over here and adding a try clause, right? So when we add a try clause, we can put a tab statement over here and add an except statement and print the message that we want to print in case this particular exception occurs, right? So exception has occurred. We do that and we click on play. So we can see that instead of this particular statement executing and giving us a name error, we can see the message an exception has occurred, right? So next up, what we can try is something different. We can write over here, except name error, right? So this is the category of exception that we want to deal with specifically instead of dealing with all of the exceptions. That is what happened, right? So if we play this as well, we can see the statement exception has occurred, right? So let us try something else with this. We can also add a finally clause over here or an else clause. Let us first try an else clause, right? So when we add an else clause, we can type print no exception has occurred, right? When we do that and we click on play, it still gives us the message exception has occurred because the exception is actually occurring, right? But instead of that, if we simply change the B to 1, right? Now the statement should successfully execute because there is no exception over here now. We click on that and it'll simply print no exception has occurred. And if we type something like print A over here and click on play again, so it'll first print the value of A in the try block, right? And then it'll go to else and say no exception has occurred. So next up, we can try something else. Let us try the zero division error. So in this particular case, what we will do is A equals to 100 modulo 0. Let's try that. And print A, right? Now we can type except name error. So we know that this is not the name error, this is the zero division error, right? But we'll still write that and we'll see which exception is actually caught, right? So print name error has occurred except zero division error will print zero div has occurred. Then we play that and we can see that instead of this particular exception printing, the zero division exception has printed, right? So since we did not catch any name errors, the zero division error was caught when this particular statement tried to execute, right? So instead of that, if we simply go over here and change this to 1, right, it'll simply print the actual output. So when we divide 100 by 1, the remainder is 0, right? We can add something else over here, which is called the finally block, and print hello, right? So in this particular case, what will happen is we play this and we get the 0 from the try block and the finally from the hello block. But that is not all. Say if we change this back to 0, right? Now this means that we get the zero division error once again, right? So now what will happen is we'll get this statement, which is zero div has occurred, in which in this particular case the error was caught, the zero division error, and then the finally block was executed regardless of whether the try block executed successfully or an exception block executed, right? So that is how the finally block works. And finally, to look at the last error, which is the try, which is the type error, we'll simply type try b equals to hello plus 17, which is an integer value, right? We do that. We type print over here, type b. We go to except, and we type in the type error, which is the error that we are probably going to catch over here. Print type error. We do that, and then we can try to add an else statement over here. Print uh, the print statement over here will say something like no exception has occurred. And finally, we get the finally block, which says I am going to print regardless. Right? So when we try to execute that, we can see the exact workflow of how this is working out. So the tried statements tries to execute. We get this p equals to hello plus 17. This does not execute because there's a type mismatch, the data type mismatch, string and integer. We go to the type error, right? Now, since an error was actually encountered, an exception was actually encountered, the else statement will not execute as well. So this statement will not execute because error was encountered, right? And then finally block that we have over here will execute regardless because it executes regardless anyway. So if we simply go back and change this to say 11, which makes this a valid statement now. So it'll change the output. So firstly, we will get the 28, which is 11 plus 17. We get the 28. We get the output from the else statement, which says no exception has occurred, no exception was encountered. And then finally, we get the finally statement anyway. So I am going to print regardless, right? So this essentially explains how exception handling works in Python. Now, additionally, we have the option of raising exceptions as well, right? So we have the option of specifically specifying conditions in which we would raise exceptions instead of relying on the predefined exceptions that Python already gives us. So say if we want to throw a type error or an exception in general. So let us type in something like x equals to 14, right? So this is a value and now x is equal to 14. Now what we can do is simply type in if x is equal to 14, in which case we will write if x equals to 14, and then given the condition of that particular statement, and then what we would do is raise an exception. This is an exception is the message that we're going to use. So when we do that and click on play, it throws that particular exception, which is this is an exception, right? So we can even configure Python in a way, or we can configure our code in a way to throw exceptions on our custom predefined conditions, right? So the raise statement is used for that. We can also do other exceptions with this particular statement. Now, if I simply start a code block again over here, right, I can raise another exception. Say, for instance, I type in a variable. Now I give the variable a string data type. So let us call this string data. Right now, what we will do is we will check the type of this particular variable. Now, to do that, we'll simply type in if not type a. Now we're checking the data type is int, which is the data type that we're actually checking whether the a variable is of integer data type or not. Raise type error and say that integers are allowed. When we do that and we click on play, we get an exception which says the exact message that we typed in, which is a type error and integers are allowed. So that was the example of how exception handling works. I hope you understand the workflow of it and the exact pattern of how these exceptions occur and how you can handle them very easily. You can also see how you can create your own exceptions by using the raise keyword.
If you want to make a career in data science, then Intellipaat has IIT Madras Advanced Data Science and AI Certification Program. This course is of very high quality and cost effective as it is taught by IIT professors and industry experts.